So hi, thanks. It's a great pleasure to be here in Lisbon, not just because of the nice weather and food, but I'm very proud that NXP has embraced this open source project, and maybe 1 year after started to be able to contribute. It's I mean, as a semiconductor company, collaboration and openness is maybe not the default state. So yes, nevertheless, nice to be here and part of this event. So I'll tell you, so I'm really speaking on behalf of the development team which produced this p3com project today. So unfortunately they couldn't travel to the event, but Jakub Sosnovec is the lead developer for this project, and Stefan Swartz is the manager of our new vehicle operating system team for our automotive processing division. And I'm a solution architect for our automotive processing business unit. So they'll be on the line as well. So I'm not sure if the setup facilitates them to be able to speak and be heard and hear if there's questions, but if not, we'll take things offline if I can't answer any questions. That would be good. Yeah. Let's see. Okay, so the presentation I'll introduce by explaining the motivation, the background for the p3com project, and as this project is really an integration, I want to explain the relationship between this project and two existing well-known projects by the name of Cyclone DDS and ISORIX. And then I'll explain what the p3com component extends or integrates in addition to those components. And then I'll finish just by showing some benchmarking results. This ultimately what is important for NXP in the SDV context is to make sure that any new technologies or software is running in an optimized way on our microcontrollers and microprocessors at the end of the day. So. Yeah, about the motivation. I mean, so this is a middleware project, and so the speaking to the motivation in general, we want SDV applications and services to be able to communicate seamlessly and efficiently without any specific underlying knowledge of the interfaces which connect those applications and services. So everything should be able to communicate without having precise knowledge of where that is in the system, and so on. And so the motivation for us in p3com is to expose all of the high performance data interfaces that we have to those DDS APIs. And so this really arose as a specific need for us when we were working with the Blue Box 3 system, which is our platform that we use to develop ADAS and autonomous driving. And the situation we really have here is that we're feeding in video streams from cameras. We have AI accelerator cards and mass storage. And so we need to be able to very efficiently share video frames between those accelerators and the camera interfaces. And what's unique about this setup really is that we have our Layerscape microprocessor connected to our S32G vehicle computer using a PCI Express lane. So in this project, we would like to be able to use the DDS API, but to be able to use the PCI interface to be able to be the transport for that communication. In addition to this, I'll give you another example. So this is the block diagram of our S32G2 microprocessor, and in there there's a combination of Linux cores which would be running on a A53 and real-time controller cores which are M7, which would be typically running FreeRTOS. And then we have a high-performance memory on chip which facilitates communication between the Linux application and maybe a safety application that's running on the M7 core. And so that's the background. So as part of this project, initially we'd started to develop a bit of a DDS API, but quickly realized that this middleware space is there's many options out there to use. And so in the end, the project ended up embracing the Cyclone DDS which is a well-known data distribution service protocol and API, which is widely used. It's a very rich API and it's also very efficient. So we decided to use that within this project. In terms of Eclipse iSORX, it's a high-performance inter-process communication middleware, which ensures that you can share data between processes without any copy of the data. So again, it's very efficient. And the way these two projects work together is that the Cyclone DDS also has optimizations to use the inter-process communication using the iSORX. So both mechanisms are there. And so again, when it comes to p3com, the motivation is to really enable these, extend these existing software components by enabling platform-specific interfaces on that system. So we really wanted to enable the DDS API to use the PCI Express and our shared memory messaging. And so as such, we've extended it by creating the concept of gateways and transport gateways. And so in this case, we created a p3com gateway, which listens to the iSORX shared memory communication, and it uses the PCI Express bus when it needs to. Similarly, we have in NXP, we have a software component called IPCF. It stands for Inter-Process Communication Framework. And so again, we implemented this as a gateway plugin, which would allow the shared memory communication between the Linux world running on the Cortex-A53 and the FreeRTOS running on the microcontroller core. So let me explain a little bit about the way we came up with the name p3com as well. It stands for portable, because this is operating both on Linux and FreeRTOS operating systems. It's pluggable in the sense that we want to develop this modular transport layer architecture. As I mentioned, the modules we have for PCI, IPCF, it also supports UDP and TCP. And there's been other ideas floated as well about potentially extending this with a CAN module as like a failover communication for this protocol as well. So it's very possible to extend this with other platform-specific transports, which include other processors and platforms other than NXP as well could also implement these modular plugins. And yeah, finally, the last P is for publish subscribe, which is the default communication pattern that's supported by this by the DDS API. And we're also exploring extending it by using other communication paradigms as part of that as well. So it really consists of platform agnostic infrastructure, which is really the things like the discovery mechanism. So yes, so p3com is implemented as a daemon process, which would then forward the iSORX traffic over the transport layers that it requires. And then, yeah, as I mentioned, the platform-specific elements are the gateway components. Yeah, so in terms of performance, I think what we're showing here really is a comparison between the vanilla Cyclone DDS performance, which uses UDP as the transport, compared to when we integrated the PCI communication as the transport between those. And so really, I mean, the takeaway message from that is if you use transporting large amounts of data, then we're really able to exploit almost the full capacity of the PCI Express connection between those two systems. So I think we're showing that during this transport, we have very low overheads, and we're able to almost exploit full capacity of the PCI Express within the system. The interesting thing you might notice there as well is that for small payload sizes, actually that the default transport mechanism possibly outperforms the PCI Express implementation as part of that as well. So I think the ideal situation is use the right transport for the right type of message. You might be interested more in terms of latency as well than the overall bandwidth. And so yeah, I think that's it. That's the final slide. I'll leave this one up here because I think it shows the p3com in a nutshell, and I'll open to any questions.
I don't think he.
Yeah. Question is, do you have any idea why the small messages have lower performance?
I'm not sure. I'm not sure if Jakub or Stefan, who's on the line, would be able to answer that question as well. Is it possible to have
Jakub online, you mean?
Yeah.
Okay, while we wait, is there any other question?
Yes.
I was wondering, is there a particular reason why this is not simply a contribution to ISORIX?
It is actually. So there are Jakub has also been contributing to the ISORIX project, and one of our contributions there is also the porting to FreeRTOS of that as well. So there's that. Yeah.
Project, right?
Yeah, the ISORIX itself is still a separate project.
It's a new project that you.
p3com is a new project.
Why isn't it simply a contribution to ISORIX? Why is it a separate project?
Yeah, I'm not sure I could really answer that one as well, but it's really, I guess, everything together, including the platform-specific gateways that are integrated there. I suppose it would be possible to integrate that way as well. Yeah.
Done?
Yeah.
Hi, Thomas. Thanks for the slide. I'm Pratik from 42 Wolfsburg. I'm struggling to understand the project where the emphasis on designing the middleware and introducing the IPC layer. Don't Eclipse already have two projects, which is Sommer and EBG by Microsoft, which also works in or tries to provide the same solution?
Yes, but I would say the thing that's unique about it is being able to use PCI Express as the underlying transport.
Okay, is it possible to just put that feature as an add-on on already existing solution? I mean, why I'm emphasizing this is, as Michael mentioned, the different islands and putting the bridge in between. I think this is a good potential or opportunity to not reinvent the same solution on 3 different islands, but to just merge and make the one with.
Yeah, I think so. No, I think it's a very similar comment to the last question as well. I mean, the last presentation we gave about this project as well was we tried to present it as not another middleware, because as you mentioned, there's a lot of overlapping solutions. So yes, it's an approach, as I mentioned, is NXP. I think the thing that we want to enable is any underlying platform-specific optimizations that could be provided to support those middleware. Then we see that as a good thing. So yes, I think it is also a possibility to enable those modules within other projects such as Sommer or eCal, or whatever it is. Yeah.
Thanks.
Can you hear me?
Yeah, we can. Go ahead.
Yeah. All right. No, I just wanted to. Hello. This is Jakub. The kind of the development lead on this project. So I just wanted to answer maybe. Okay, I heard the first question about why we are actually slower here with PCI Express compared to Ethernet. Well, that's mostly just of how the underlying PCI Express sort of driver stack is designed. It's really not that optimized for this case, because really where this performance shines is in the large payload, large payload messages which are bound by the copy time, right? As compared to the small ones where it's more about trying to, like, the overhead of the protocol is dominant here rather than the copying itself. And there it's quite difficult to actually compete with Ethernet, right? So that could be the reason why, yeah, for like small messages, just like normal UDP is really, really fast. The pipeline is really well optimized there. So as Tom said, the ideal here would be like a hybrid set where you maybe can individually with a quality of service setting configure topics and just use the p3com transport layer like PCI Express for topics where it makes sense. So I hope that's kind of clarifies. And maybe I think there was also a question of whether this could be actually contributed to Isorix itself, which I think that's a really good question. So p3com is really, it's an extension of Isorix, right? So it's like it's just an application basically that builds on Isorix. I don't think it should be merged with it because it doesn't. We actually don't want to make a fork of Isorix. We are basically just extending it with some additional functionality, which is kind of completely decoupled from any changes in Isorix core, right? So it's a super related project, but I think it makes sense rather to keep it separate.
Okay. Thanks, Jakub. Okay, thank you.